Hello class, this is Building Construction for the Fire Service, Chapter 13, Specific Occupancy-Related Construction Hazards. This chapter will cover a wide array of specific occupancy-related construction hazards. It includes more than 20 building types and identifies the unique hazards and firefighting concerns associated with each. There is a lot in this chapter, so make sure that you take notes. And remember that you can go back and forth between slides if you need some clarification. The objectives we're going to cover in this chapter are that we will determine the unique design and construction details found in buildings based on occupancy type. We will establish how occupancy-specific building code requirements dictate particular safety features. We will identify the unique details and hazards associated with specific occupancies and understand how occupancy specifics affect firefighting operations. Now let's talk about occupancy. Occupancy is the type of use and it plays a role in how the building is constructed. We will also talk about how occupancy types and building hazards involve details related to codes and are city specific, and the codes in your locale may differ. In other words, they will differ from locale to locale based on city ordinance and county ordinance sometimes, etc. Let's talk about apartment buildings first. Specifically garden apartments. Arthur Brannigan is the man who investigated low-rise combustible multiple dwelling fires for the Center for Fire Research of the National Bureau of Standards, or the NBS. He worked to determine why fires extend beyond the area of origin in a protected combustible construction building. With garden apartments, combustible multiple dwellings include garden apartments. Also, they include modern row houses and townhouses. Condominium is not a useful descriptive term for firefighters. A condominium is basically a garden apartment that you actually own versus rent. In terms of fire, the term condominium is useless. An apartment is apartment in terms of fire spread. Some characteristics of garden apartments. They can be made of various materials, including solid masonry, brick veneer over platform wood frame. Sometimes they have partially solid masonry, particularly brick veneer on wood, and sometimes they're just outright wood. There's a height limit to garden apartment buildings. Usually there are 3, sometimes may have 4 stories. And it can be difficult to reach victims at rear windows of top floor apartments. And they're usually, of course, individual living units. In terms of individual apartments, they're usually confined to one floor. In other words, if it had a downstairs and upstairs, that would be a townhouse, which we'll talk about in a moment. But with garden apartments or apartment units, they're usually confined to a single floor for occupancy. Some are multi-floor units, but more often than not, they're confined to a single floor. And some apartment buildings, some of their structures may have both one floor and multi-floor units, so it can be kind of a mixed bag. Very often apartments have balconies. It's customary in many apartments, and they can be combustible or non-combustible construction. A lot of times they provide normal access to the apartment, but you can have cantilevered balconies and they can collapse in fires. Sometimes apartments will have gable roof attics, which extend over the entire structure, in other words, over the entire apartment building itself. And attic fire barriers are frequently not effective because they have been compromised very often. Modifications over the years. Let's say it's an older building and they went back later and put in HVAC, etc. There are very often peaked roofs, particularly in northern latitudes where you have snowfall involved. These are dangerous to firefighters, and they must have a pitch to drain rainwater or snow. But the pitch creates a void between the tops of the horizontal ceiling beams and the sloping roof, and fire can spread laterally through this space. With interior construction, it's usually almost totally wood, and this multiplies the fire extension potential through the voids inherent in combustible construction. In regards to plumbing fixtures, they're usually vertically aligned and the piping is run through vertical voids. There are structural members that are weakened very often by cutting, and there's always a potential for collapse hazard due to the weight of fixtures, structure cuts, and air supply via interconnected voids. When escaping a burning structure, in terms of escaping a single roof ranch home, that's easier than from the top floor of a combustible multiple dwelling. Stairways, enclosures, and attics overhead are very often combustible, of course, and stairways are safe for no one. Very often it boils down to educating the management and the tenants. And the owner must be fully insured for the value of all personal property. Now, residents should also buy fire insurance. It usually is a rider that's attached to your car insurance, and if you ever have a conversation with anybody about fire and apartments and things like that, which hopefully when you're out in the community you do have these conversations, you need to make sure that they understand that the owner is going to be insured for the building and any of his personal property that is attached to the property itself. But in terms of the interior contents, that is up to the individual apartment dweller to have insured. People who dwell in apartments should keep property of unique value in a bank vault. With parking, space is generally limited. Requirements include a minimum of 20 feet of clear width, proper turning radii, red striping of curbs, and signage. If you drive around and look at properties, 8 out of 10 times this is not designated properly. If you're lucky, they've got a fire lane and a fire curb marked off in red. The owner is responsible for making sure that illegal parking is eliminated, but they don't often. So when you roll up for a scene involving an apartment building or a set of garden apartments, you're often dealing with sometimes dumpsters are in the wrong place. People have kids leave their bikes in and around fire lanes. Some people just ignore signage if there is any and park in a fire lane, or they're parked illegally otherwise. So those are all things that you need to be aware of that you may encounter with apartment buildings and parking. In terms of building location, there should be a map drill that makes good indoor planning exercise. People don't always do it. They should make a map of their apartment and how the heck they're going to get out. Drills identify special difficulties that make it difficult to get away or get from point A to point B. Building owners should be encouraged to provide lettering and numbering on buildings. Some jurisdictions are pretty strict about this. Others, unfortunately, are not. In regards to natural gas service to apartment buildings, natural gas provides special hazards in these types of structures. The service layout usually involves little or no thought for the safety of firefighters, unfortunately, and meters are typically grouped together and represent a substantial weight, which means that's weight bearing on a wall, which is subject to collapse. So when you're out and you're getting to know your jurisdiction, or you go out for fire inspections, classes, and things like that, these are all things that you should become aware of. Be aware if there's a common gas metering wall, which unfortunately you will find more often than the case is that those meters are attached to a wall. If you're lucky, the meters are grouped together but standing away from the wall. But be aware that they do represent substantial weight, and if they're attached to a wall, that's potential hazard, aside from the gas itself, of course. One case example is gas lines that were located below the ceiling of a passageway between chicken wire lockers provided to each tenant. Now, you'll see this very often in inner city apartment buildings, definitely in the Midwest and Northeast. You have in the basement these chicken wire lockers. So in this case, gas lines were located below the ceiling of the passageway between chicken wire lockers provided to each tenant. A fire engulfed some of the lockers and one of the hangers gave way. 20 gas pipes overhead fell down to the floor. The pipes failed, gas was released, and another fire was ignited. Where there is no utility gas service, liquefied petroleum gas or LPG storage tanks may be used. One case example is in Anne Arundel County, Maryland, actually where I was born. Home of the U.S. Naval Academy. In Anne Arundel County, Maryland, an apartment complex was served from a single large gas tank. Its regulator failed and many fires arose simultaneously through the complex. In regards to water supply, hydrants are often on private mains. They should be checked periodically. Older complexes often have undersized mains. When the mains went in, it might have been perfectly adequate for the property, but if they've carved up more apartments into a building, or there are more buildings on a certain property, the mains aren't always adjusted to compensate for that. So older complexes often have undersized mains. The owners need to conduct flow tests. With protected combustible construction, this is in regards to apartment buildings still, you have fire-rated gypsum board sheathing or shell of the structure that prevents the spread of fires. Gypsum has excellent fire protection characteristics. It is the only construction material that does not yield heat when burned in pure oxygen. So gypsum is excellent for, it's often used as a firewall between apartment units, and if the building is meant to be used for condominiums, very often it's written into the mortgage and fire inspection characteristic or fire protection characteristics of a loan for insurance purposes. In other words, no one's going to write homeowners insurance on a condominium that doesn't have a gypsum firewall enclosing the unit itself, because again, this is not just an apartment, it is private property. The effect of fire on gypsum board, we already said it doesn't yield when burned in pure oxygen, but calcification occurs when gypsum board is heated by a fire. This process appears to be irreversible, so removing all burned gypsum board makes the most sense. If a unit has gone through fire, it's protected by gypsum board, it's going to get calcified, or calcination occurs, and so ultimately you have to remove it, but that's better than the entire building going down. So it is really good material. The fire rating of gypsum board in terms of the National Fire Protection Association Standard 251 and the American Society of Testing Materials ASTM Standard E-119, these fire-resistant tests grants a 1 hour or greater rating between these two standards. A myth: gypsum board possesses the magical ability to limit the extension of fire. I've said in previous chapters and in other classes, eventually everything's going to burn, given the right circumstances and temperatures. So the rating of gypsum board cannot be separated from the test structure of which it was a part. So it's only as good as the test structure itself. And bear in mind, while it is a fantastic material, It's used to separate units to prevent fire spread. Eventually, everything will burn given the right circumstances and temperature. Underwriters Laboratory, or UL, warns that gypsum board rating is not assigned to individual components. So it's testing a structure protected by a gypsum board enclosure as a whole, not the individual components. In other words, there might be one or two flawed components in that overall structure. With gypsum board installation, it is commonly nailed up over voids with a large or even infinite air supply behind the board. In other words, ample air exists to continue combustion. Nailheads often are not properly cemented over. They must be, otherwise they heat up and cause problems. Very often the joints are not properly taped. Nothing is ever added for an extra margin of safety. Now let's talk about, we're still talking about apartment buildings in terms of protective sheathing. Protective sheathing protects the combustible structure from a fire in the contents, but a single hole can cause disaster. Penetrations of the gypsum sheath range from pinholes to sizable openings. We talked about cementing over nail heads. This is a potential problem that can cause this type of situation. Any penetration allows fire to spread through the structure, thus converting its contents from a specific fire to an overall structure fire. With penetrations, a failure to close gypsum sheath around utilities such as electrical or gas service can be a problem. Also, failure to install the gypsum sheath behind the bathtub, also a major problem. Open doorways are sheathed in gypsum, but the thin wood door casing is sometimes the only sheath. Fire can ride the ventilation airflow in attics. Floors are easily penetrated downward by a fire involving today's types of fuels. There is no such thing as a rated top floor / attic ceiling. Why? Because the hot gases tend to flow up and concentrate the heat upwards, and as I said before, everything's going to burn given the right temperature and circumstances. So there is no such thing as a rated top floor or attic ceiling. Dangerous hidden voids are prevalent in the rehabilitation of older buildings. Protected combustible, quote unquote, is not fire resistive, quote unquote. Floor and ceiling assemblies and interior walls can be rated according to ASTM standard E-119. The fire-resistive characterization should be rejected. Even protected combustible can be overly generous. They're just misleading terms. They suggest that things might be a little bit safer, but that's the way it needs to be regarded, not I'm fully protected now, just like the unsinkable Titanic. Firewalls and barriers and draft stops. Let's talk about these. Firewalls are often used to separate units in multifamily residential structures. There are many possible defects in such walls. The primary defect involves not bringing a masonry firewall through the roof with a masonry parapet. It is almost impossible to fit masonry tight to the roof. In regards to overhangs or mansards, permitting them to project beyond the firewall is another defect in firewalls. They provide a gap for fire to pass around the end of the wall. Permitting the firewall to end at the interior of a combustible exterior wall enables fire to pass around it. Fire is something like water in that water tends to always find the path of least resistance. Fire does the same exact thing. Now let's talk about utilities. Utilities are often passed through the firewall. There's that penetration or opening we were talking about earlier. These openings around pipes end up passing fire, of course. It is better to run utility mains parallel to the building with branches into each unit. Unprotected openings frequently are cut into firewalls, compromising the firewalls. Then you have openings at the basement level. These provide access to storage and laundry areas. They're usually designed and built with proper self-closing doors. But often, unfortunately, doors are blocked open. And I'm sure you've been somewhere, and maybe even in your own building at some point. You see a sticker on the door that says, "Fire door, do not block or prop open." And there it is, blocked or propped open. Firewalls as a party wall. These create problems. Party walls often have beams or girders from both sides in the same opening. Common openings provide a path for fire extension. With older row frame buildings, they often had brick laid in the party wall stud voids as a firewall. You see an example of that in this picture right here on this slide. The barrier is incomplete, and the brick nogging, which is the brick and mortar filling between studs, does not block the floor or attic voids. With fire barriers and draft stops, these are intended to limit the combustible void area in the attic to which fire has access. Plywood or chipboard is used for the draft stop. Some barriers are now being made of 2-inch gypsum plank. They are cut into the field to meet the slope of the roof. These cuts produce openings for fire access. In terms of effectiveness of the fire barrier, and again, all this time we've been talking about apartment buildings, and we're still on apartment buildings. In terms of effectiveness of the fire barrier, this may range from temporarily reliable to totally useless. They're never as good as a parapeted masonry firewall. There are also defects in fire barriers and draft stops, and a fire can delaminate and raise up plywood so the fire passes more easily. The barrier does not extend out to the eaves, but stops at the wall line, thus allowing the fire to go around. With omitted nail covering and joint taping, which we talked about before, utilities or structural elements passing through these also, and doorways that are cut into fire barriers, and the use of scraps of gypsum board all affect the integrity of fire barriers as a whole. When fire barriers are above the midpoint of a room, both sides of the barrier are exposed to fire coming out of the windows. A fire barrier is placed even if it doesn't continue a fire separation below. Now let's have a word about sprinklers. We're still talking about apartment buildings here. With automatic sprinklers, they extinguish content fires, but will rarely control any fire that originates in or extends to the voids. In FPA Standard 13R, which is the standard for installation of sprinkler systems in low-rise residential occupancies, is a tremendous safety feature. Unfortunately, some states do not require enforcement of this, and or landlords do not always comply with it. In FPA Standard 13R, which discusses systems and garden apartment complexes, states that they often share the same water main with the hydrants that are in the complex. Hooking to a hydrant can take water from the sprinkler system itself. Now let's talk about serving the citizens for apartment buildings and condos. These are homeowners. They have personal property or homeowners insurance, and I talked about renters insurance. Sometimes these policies are too inexpensive to be actively sold. And renters suffer crushing financial blows from fires. So it's very important that if you talk to people and that they understand that they need to carry on their car insurance, they can carry renter's insurance as a rider. The fire department should create a system / firefighting plan the day an apartment development is planned. Now let's talk about brick nogging. This is a crude attempt at a fire barrier, and we talked about it before. It's that brick that's put in between these stud beams. Brick nogging does not cut the floor voids or the caulklift, and brick or stone nogging can serve as a heat sink for winter warmth. And that's partially why it was constructed. But this presents an additional hazard in collapse. So not only do you have the normal things that are common to collapse, but brick nogging can let go and drop a heap of bricks from between these stud beams. Now, we talked about apartment buildings or garden apartments before. Now let's talk about apartments and specifically townhouses. Now these can be privately owned or rented, just like garden apartments can be rented apartments or condominiums. Doesn't make any difference. The construction is the same. So in this case, we're going to be talking about apartment buildings, specifically townhouses. Townhouse is just nothing more than a new name for row houses that I talked about a couple of slides ago. Rarely in townhouses does an adequate masonry firewall exist between the separate buildings. So you see in the slide this picture, this one on the end, it's a huge townhouse, but you see the front door, and then you see the structure next to it, and you see the front door attached to that one. That wall in between there is what they're talking about. 9 times out of 10, it does not have an adequate masonry firewall that exists between separate buildings. Now, oddly enough, the brownstones that New York's so famous for, that were built at the end of the 19th century and into the early 20th century, those actually do, because they were built by wealthier New York citizens, and they demanded isolation from their neighbors, even though they shared a common wall. Very often there were 2 walls there jammed up together. They wanted to not hear their neighbors. They wanted to, their house was their house. And so that is the exception rather than the rule. So rarely does an adequate masonry firewall exist between the separate buildings. And separate is a loose term. You can see they're actually joined together with a common wall. Without such a firewall, the entire structure is all one building, as you can see. Now let's talk about tenement houses. These began in the 1800s, but now imply substandard housing. Now, a lot of these have been redone, brought up to code, and are better, but there's still an awful lot of tenement houses out there. You'll see them in downtown LA, virtually every inner city. These present multiple firefighter problems. Vertical fire will spread through voids, and a horizontal fire spread will go through the caulklifts, and compromise is always present in open stairwells. You also have fire spread via shafts. Sometimes these have elevators in them, and air shafts, etc. New York City updated tenement regulations in response to devastating fires. And if you do a little bit of research, you'll see some horrific tenement fires that occurred in the city through the generations. So now the standards require better enclosures of stairwells, more substantial apartment doors, exterior fire escapes. Now let's talk about 3-decker. This is very common in the Midwest and Northeast. You don't generally, you see this in San Francisco. Now you won't see it, there aren't as many of these as there used to be in San Francisco. Of course, in 1906, the earthquake destroyed a lot of these. But you'll see them occasionally. You won't really see them in LA, but you'll see them in a good deal of the country. The 3-decker is, as I mentioned, typically found in New England. These are 3-story flat roof structures with 3 apartment units. Basically, 1, 2, 3 stacked right on top of each other. They're quite charming, but they do present some problems. They have porches on each level. Now, the porches in 3-deckers play a critical role in fire spread. They offer a large surface area on which fire can burn. If you've ever seen movies that are set like in Boston, you'll see people hanging out on the decks of their 3-deckers or row houses, and they often have substantial porches. But that's a big surface area, generally constructed of wood. It gets dried out in the winter because of salt and stuff. So when it comes summer, people don't always treat the wood like they're supposed to, and yeah, it can provide a large surface area for burn. Now let's talk about atria, or atriums, as people incorrectly use them, or atria is the plural for an atrium. With atria, this is a large open space within a structure connecting 2 or more floors. These are large voids that pass through multiple floors, allowing smoke and heat to move vertically through the building. There are specific code requirements for atria. They must connect a minimum of 2 floors, and there is no minimum size requirement. Full sprinkler protection is required throughout the building, and a smoke control system must be present to minimize the movement of smoke. There must be standby power available for the building, and the floor of the atrium, a specific single atrium, is limited to low fire hazards, but 3 floors are allowed to be open to the atrium. So read about this in your book there. It covers it a little more specifically. The 3 levels open to the atrium must be included in the calculations of the smoke control system design. The volume of the open space is included in the sizing of the exhaust system. The system must exhaust smoke from these areas. Designs often neglect to provide a means for exhausting these areas, unfortunately. In regards to atria and the smoke control system, activation is usually triggered by water flow and smoke detectors. Projected beam detectors are used in smoke control systems. These detectors can cover large areas with a single beam of light. Firefighters should know what the system can and cannot do. In regards to sprinkler protection in atria structures, it's usually straightforward with buildings. It's usually straightforward in buildings that have an atrium. Atrium and floors open to the atrium are zoned separately from the sprinklers in the rest of the building, with a separate riser for each. So you get a riser for the atrium area and a riser for the other parts of the building. In regards to atria and national experience, there are limited experience with actual fires in atria. However, there is one case example in 1991. A fire occurred in the Polo Club high-rise in Denver. Although the building had an atrium, it had no sprinklers and no smoke control system, only skylights at the roof. Another case example is the Grand Californian Hotel at the Disneyland Resort in Anaheim in 2005. You probably remember seeing this on the news, perhaps. Lights on an artificial Christmas tree ignited, burning off the top third of the tree. Sprinklers contained the fire as 2,000 hotel guests were evacuated. So in this case, it worked like it's supposed to. Now let's talk about houses of worship. These are often open area structures. They have sometimes large occupant loads, especially during the holidays, and people often bring, or worshipers often bring candles and combustible decorations. A case example of this going wrong is the San Antonio church erected a quote-unquote living Christmas tree. The tree presented many safety issues. Now, with older churches, sometimes they have multiple levels of seating, and you've probably seen this where you have like a balcony section in the back. You might have even a multi-tiered level of seating. So sometimes older churches have multiple levels of seating, and there are sometimes galleries that surround the main sanctuary, and often narrow staircases that impede egress. Also, of course, you have stained glass windows. They're valuable for ventilation, but invaluable in terms of cost and heritage. Also, you have steeples and bell towers. Collapse of these have cost firefighters their lives, and sometimes, unfortunately, worshipers as well. There was a big church fire in 2004 in Pittsburgh. I encourage you to look up and read about that. And you can see in the picture the steeple and bell towers all gone, along with the ceiling, whatever ceiling there was that surrounded those structures on the inside, gone. And you can also see it blew out and burned out all the windows. Now, with houses of worship, very often they're under renovation, especially if they're older. You can have cutting and welding operations, burning off of old paint, and other construction activities that have ignited numerous churches and synagogues. A case example, in 1998, New York City Central Synagogue had a blaze that resulted from workers installing an air conditioning system. Now there is the structure known as a covered mall. Covered mall buildings are a single building enclosing a number of tenants. Anchor stores, large stores attached to the mall, have all of their required exits independent of the mall itself. There are some recent building codes relating to covered malls. These recent building codes have allowed covered mall buildings to be of an unlimited area. They're predicated on the use of type 1, 2, 3, or 4 construction and having 60 feet of open space around them. If you need to, go back and review construction types or use types 1, 2, 3, and 4 and what those types of construction are. With covered malls, you can have vertical spread of heat and smoke in a fire, but malls have the added problem of horizontal spread of heat and smoke. None of the tenant spaces have a fire-rated separation from the mall itself, except for large anchor stores. Malls have large occupant loads. In terms of physical separation between tenants, that separation must be fire-rated, but it need not go to the floor or roof deck above. A roll-down grill type gate will allow smoke to move into the mall proper from an individual store or stores. In terms of fire protection in malls, they include complete sprinkler protection, a smoke control system, a standpipe system, an emergency voice communication system, and standby power. System requirements involve required analysis during your pre-planning. So we talked a lot about pre-planning in other classes and in previous chapters. But cover malls required analysis during your pre-planning. The sprinkler system will often be separately zoned for the mall proper and the tenant spaces. Feed mains supplying the tenant spaces will run along the front of the store. The standpipe system in covered malls is a Class 1 system. It will have hose outlets in the mall at the entrance to each corridor and exit passageway, which is a more substantially fire-rated corridor with limitations on openings into it. Outlets are also at each floor level in stairwells and at exterior public entrances to the mall. The smoke control system in covered malls are similar to that used in an Atria type of structure, or what is used in structures that have Atria. There are attempts to minimize horizontal movements of the smoke. The smoke control system attempts to minimize horizontal movement of the smoke, and it also attempts to exhaust smoke through the roof over the mall. With covered malls, there are usually city requirements, and some require a standardized lettering and numbering system. These letters designate blocks or rows of stores, and numbers indicate particular tenants. Now let's talk about factories. Factories, of course, still exist all across the country. Most have production equipment, which can pose safety risks to firefighters. Hazards include large moving parts, confined spaces, pressurized vessels, and heavy-duty energized electrical equipment. In a smoke-filled environment, firefighters can easily get injured. And remember, in some of these locations, you also have autonomous or semi-autonomous robots, and they're supposed to have safety cages around them and things like that, but they're heavily energized, the lines that run to them, and so you need to be aware of structures around these types of units, and also be aware that they are, like other parts of machinery, and as mentioned here, heavily energized. In factories, the weight of the machinery in a building can cause collapse. Sometimes you have machinery that's braced or bolted to wall structures, and sometimes you have factories, not typically, but sometimes have factories where you have lower weight equipment on a floor above, like the main factory floor. So be aware of that. The factory building itself often has circular stairwells. It can also have ship's ladders, which are completely vertical stairs with a width that is not more than 24 inches. Open loading docks, limited access, including lack of windows, often occurs or is often found, and adjacent storage or warehouse areas are often found. Now let's talk about hazardous materials production and storage. Hazardous materials include the more familiar flammable and combustible liquids and sometimes more exotic substances. Pyrophoric gas is a gas that ignites in air without the introduction of an ignition source. Now let's talk about fire codes in relation to hazardous materials. Hazardous Materials Management Plan, or HMMP, is required in most codes. It explains how hazardous materials are to be used, how to be stored and safely used within a building. These are all required on a site that has or uses and or stores hazardous materials or manufactures them. And Hazardous Materials Inventory Statement, or HMIS, is required in most codes, in other words, jurisdictions codes. These list the materials, hazards, and quantities of hazardous material products within a building. If you've taken any hazmat classes like first responder awareness, you'll be aware that also you will encounter material safety data sheets. These sheets that we're talking about here, the management plan and the inventory statement, are in addition to those. With hazardous materials, there are limits on quantity. Codes specify types of hazardous materials that may be stored and or used in a building. Exempt quantities are permitted without requiring extensive safety features. Exempt quantities are permitted in control areas, which are essentially areas surrounded by 1-hour fire-rated assemblies. The fire code in turn allows for multiple control areas. When the amount exceeds the exempt quantity, you have numerous construction requirements that apply, and special systems or building features will be required. Now let's talk about explosives. Building codes require that they be handled in buildings with substantial fire-resistive construction. This almost guarantees the restraint that increases explosive destruction. Explosion venting is required for specific explosive hazards. Buildings that house hazardous processes, they used to be isolated and built of friable or easily disintegrated construction elements. Another method employed a steel frame covered with an easy-to-replace material such as cement asbestos board. If an explosion occurred, the board became dust-like particles. Obviously, that's not used anymore, again, to be redundant, for obvious reasons. Now, in regards to hazardous materials, you often have special purpose buildings. These may be designed to channel the force of an internal explosion in a desired direction. Transformer stations are often built with heavy walls to protect one transformer from an explosion in an adjacent transformer. They may also direct the blast upward or outward. Now let's talk about high-rises. Definitions of high-rise buildings. The International Conference on Fire Safety in High-Rise Buildings defined a high-rise building as a building beyond the reach of aerial ladder equipment to reach it safely and effectively. Author Brannigan says that the principal life safety question in any building is the time it takes occupants to reach a safe environment. In terms of fire department tactics, the preceding high-rise definition is considered acceptable and valid. By preceding, I mean the definition that I just reviewed in the previous slide. Other buildings that are not high-rises, such as airport terminals and large shopping malls, present many of the same problems. Some potential problems with high-rise buildings. First of all, there's not just one single problem. Fire significant construction differences exist among high rises. So one high rise is not going to have the same fire significant construction as the high rise right next to it. With high rise building design, they're usually designed to resist the effects of fire on the structural frame of the building and the floors. Whether the design concepts used are adequate to cope with all of these possible effects is quite another matter. General classifications of high-rise buildings. An overview. Fire-resistive buildings have evolved over the last century and a half, of course. It is useful to examine buildings based on the era in which they were constructed. With early fire-resistive buildings, we're talking 1870, 1930, there were no standards for the protection of steel. Cast iron columns were often unprotected, and terracotta fireproofing was compromised by concealed lightweight conduit, which expanded and tore the tile off of columns. Some other hazards in early fire-resistive buildings. Segmental brick and tile arches were supplanted by flat terracotta tile arches. No protection was provided for the underside of the steel beams. Tile arch floors often had to be laid in an improvised manner, lacking adequate protection. The ceiling may have been lowered one or more times. Codes do not require the removal of the old tile, or did not, especially at the time. Standpipes in older buildings may be inadequate in size. Closures are not often as fire resistive as the original masonry walls. Live loads in older buildings may have increased beyond acceptable safety limits. Unprotected steel supports may have been inserted. Fire loads may have grown to high levels. Later high-rise building construction, 1930-1940, are excellent buildings. They were universally of steel frame construction. The floor construction and fireproofing of steel were often of concrete or tile. Of course, this construction came to a halt at the outbreak of the war. And then you have the era after World War II. With later high-rise building construction, 1930-1940, these involved small floor areas, and each floor was a well-segregated fire area. Wet masonry was an inherent fire stop at the floor line. Vertical shafts were enclosed in solid masonry. Standpipes were wet and immediately pressurized by gravity from a tank in the building. Exterior fire tower stairways were provided in many of the buildings. A case example, in the Empire State Building, the fire tower was built inside the building with an adjacent smoke shaft. In a 1990 fire, the interior smoke shaft became a chimney. Most fire loads were low. With modern high-rise buildings, fluorescent lights and air conditioning help to remove limits on floor area. Building populations could be increased, and many floors have substantial areas beyond the reach of hand hose streams. There's been a push to lighten and thus reduce cost of buildings, so reinforced concrete became a serious competitor to steel as a construction material. The necessity for fireproofing is an apparent cost disadvantage to steel. Reducing the concrete in the building causes the loss of a valuable heat sink. Electrical service and communication systems requirements have increased, along with the insulations that are combustible. Steel truss floor and ceiling assemblies provide useful voids for fire and smoke. By dropping ceilings, useful voids are created and then connected via utility shafts. Gypsum rather than masonry is often used to enclose elevator and other shafts. Stairways are often located in the core without fireproofing. Modern design makes it difficult to provide a real barrier to the vertical extension of fire between the edge of the floor and the skin of the building. It is often impossible to determine from the exterior which floor or floors are involved in a fire. One case example, a firefighter was seriously injured by falling glass in one Meridian Plaza fire in Philadelphia. This is a really famous fire. You need to look it up and read about it. Breaking glass is extremely hazardous because glass pieces can travel for several blocks. Energy-efficient windows resist failure in a fire and eliminate the ventilation provided by the heat cost failure of single-pane sashes. With high-rises, let's talk about the Fire Command Center. Fire Command Centers are now required in high-rises. They're typically accessible from the lobby. Their equipment includes fire alarms, emergency communications, elevator shaft monitors, emergency generator status and transfer switches, and fire pump status monitors. Fire department communication system is also housed here. Post 9/11 will typically be a radio signal amplifier. General problems and hazards with high-rises. An overview. Multiple problems can exist across buildings regardless of the area of construction. Common problems include exits, stairways, and elevators, guards against forcible entry, and occupancy. In terms of exits, they should provide a clear path to the outside. Model building codes have permitted 50% of exit stairwells to terminate in the building's lobby rather than outdoors. This arrangement is confusing to occupants. One case example, during the 1993 bombing of the World Trade Center in New York, the lobby filled with smoke, making exterior door impossible to find for trapped occupants that were on the mezzanine level. Now let's talk about high-rises in terms of occupancy. Offices, hotels, apartments, homes for the elderly, factories, and showrooms are all different. And some of these high-rise buildings have these mixed occupancies. One case example is a rigid code interpretation provided smoke detectors in occupied apartments, but none in an architect's office that used 2 apartments and had the higher fire load of exposed paper contents. There are a million examples like this out there. With high-rises, let's talk about accommodation or access stairs. Many tenants have an accommodation or access stairway installed. This is usually done as an alteration and is rarely enclosed. The result is 2 or more floors becoming one fire area. One case example, again, will reference the 1991 One Meridian Plaza fire in Philadelphia. In this case, fire was seen falling down through such an accommodation stairway from the 22nd to the 21st floor. Duplex and triplex apartments often have no exits from the upper levels. Encroachments on good containment increase the fire area and thus multiply the fire problem as they did here in this specific fire. Let's discuss forcible entry in a high-rise. Security against crime is a concern in all occupancies, of course. In most cases, forcible entry may be achieved by a gypsum wallboard on studs. Reinforced masonry is difficult to breach, and again here we're specifically talking about high-rises. There may be stairway locking that may occur to avoid re-entry. A code requires, or the fire safety code requires no more than 4 intervening floors between re-entry floors. Some codes require automatic release of locks upon a fire alarm system activation. One case example is the Cook County Administration Building in Chicago in 2003, where 6 people were trapped and killed above the fire floor in the stairwell. Let's discuss elevators and high-rises. Extrication of persons trapped in stalled elevators requires a detailed knowledge of elevator construction and operating systems. In the past, the use of elevators for fire evacuation has been considered dangerous and is universally warned against by signs placed in or near elevators. Since the World Trade Center disaster, a new generation of quote-unquote hardened and robust elevators and shafts are being developed for evacuation purposes. In some fires, all elevators may be totally unavailable to the fire department. We'll reference again the One Meridian Plaza fire in Philadelphia. In this case, all power for lights and elevators failed. This is the reason it's been mentioned 3 times already in 3 separate aspects of high-rise fires and fire safety systems, etc. is because there were so many things spectacularly wrong in this fire. So I do encourage you again to look this fire up and read everything about it. You will learn an awful lot. So again, we're going to hear in terms of elevators reference the One Meridian Plaza fire. And in this fire, all power for lights and elevators failed. In total darkness, all equipment had to be hauled up 20 or more floors. Very tall high-rise buildings have blind shafts in which elevators serving upper floors pass many floors without door openings. They're called express elevators. Shaft doors are often left for last-minute installation. Elevator door restrictors, usually taking the form of metal angle irons, have been installed on many elevator car doors to prevent them from being opened from the inside when outside the landing zone, that is 18 inches above or below the floor landing. One case example, many people likely died at the World Trade Center on September 11, 2001 in the North Tower because they could not get out. Now let's talk about smoke movement in high-rise buildings. Thermal energy is the principal smoke moving mechanism. It can be massive. For example, the burning rate of fuel in the MGM Grand Hotel fire in Las Vegas. You need to look this fire up and research it also. But the burning rate of fuel in the MGM Grand Hotel fire in Las Vegas was estimated at 3 tons per minute. Atmospheric conditions in high rises. Lapse occurs when the atmospheric temperature is constantly decreasing as height increases. Under lapse conditions, smoke will move up and away from the fire. A pause occurs if there's a layer of air warmer than the air below it. The layer is called the inversion layer, and it acts as a roof to rising smoke. Wind is a very powerful and influences smoke movement. If the windows are out and the fire is on the leeward side of the building, fire suppression may be a quote-unquote piece of cake. Now, you bear in mind high rises and wind. You can have virtually no wind felt in the lower floors, and even on a clear and sunny day. If the building's tall enough and you go up to the top, you will feel the building move slightly because you're higher up in the atmosphere and there are winds moving at that altitude that aren't moving at lower altitudes. So again, with high rises in relation to wind, if the windows are out and the fire is on the leeward side of the building, in other words, the wind is on the opposite side of the building, fire suppression may be an easy task or a piece of cake. If the windows are out and the fire is on the windward side of the building, it may be impossible to move into the fire floor itself. Closely spaced high-rise buildings can create a canyon effect as well. So that happens very often in New York. If you're just walking down the street, you'll walk down a street and you make a turn onto an avenue and boom, you get hit by a wall of wind. And what's happened is the wind may be blowing from a certain direction and it's been funneled through these rows of high-rise buildings, and you'll get blasted. It happens in any major city where you've got a cluster of skyscrapers. Wind blowing against a building seems to split about 2/3 of the way up the building. The effect of wind on the structure is becoming better understood as we've developed taller and taller buildings and we've studied more about building dynamics. We've come to appreciate the effect of wind and how it causes effect on the structure itself. Some buildings have turned mass dampers, which are heavy weights installed high in the building, and these are adjusted by computer to counter wind-induced oscillations. Very common in the newer buildings in Hong Kong, as a matter of fact, and Shanghai. With stack effect, this is the movement of air, and again, we're still talking about high-rises. Stack effect is the movement of air inside a tightly sealed building due to the difference in temperature between the air inside the building and outside the building. It is most significant in cold climates in the wintertime because of the great difference between the inside and outside temperatures. It is not caused by a fire, and the products of combustion ride this stack effect currents. Under winter conditions, the stack effect causes a movement of air from the floors into the vertical shafts, stairways, elevators, and so on into the lower portion of the buildings. If floors were completely cut off from one another, there would be no overall stack effect because there would be no connection between the floors. Smoke that has lost much of its thermal energy can be delivered to upper floors by the stack effect. One example is a fire that vividly demonstrated winter stack effect, and this occurred in a federal office building under construction in Cleveland, Ohio. The fire was in a pile of rubbish on the 9th floor. Fumes from degraded and burning plastics traveled to the top floor by the stack effect. In a sealed air-conditioned building in the summertime, the stack effect is reversed, where cold smoke falls downward. An example of that is a large fire that occurred in Norfolk, Virginia in a refrigerator plant. And I mentioned all of these instances offhand, but I again encourage you to research these fires. You learn so much knowledge, and you learn the lessons gained from these incidents that in turn have gone into improved standards for newer buildings, etc. Now let's talk about air conditioning in high-rise buildings. Individual room units that recirculate room air or draw air only from the outside will have no effect on the general situation. Single floor systems cause smoke from any fire on the floor to be distributed throughout the entire floor itself. Vents from the ducts may feed the floor above. When the entire building is air conditioned by one or more building systems, a giant HVA system, any smoke from a fire used to be recycled through the building. But more modern systems often have a true full exhaust capability. Now let's talk about smoke removal systems in high rises. Some questions to ask. Will the fire department operate the system? Will the building engineer operate it? And the answer is, that depends. It depends on the code. It depends on SOPs. It depends on jurisdictions. So you need to be aware of buildings in your area and know if your department is responsible for operating smoke removal systems, or if the building engineer is expected to operate it, and hopefully it'll be in use if that's the case by the time you respond. Continuing with smoke removal systems in high-rises, let's talk about fire control. Some argue that this can be accomplished by manipulating air supply, but there is no such thing as a clean burning hostile fire. In the fire, materials will be in various stages of degradation, generating toxic and explosive gases. With smoke removal systems, the design is an extremely complicated task. It can supplement the primary defense, but it is certainly no substitute for adequate protection. And this can be very complex in larger buildings. Let's talk about compartmentation. Some assume that fire-resistive buildings automatically provide compartmentation. This is often the case in older buildings, like the Chrysler Building, the Empire State Building, the Woolworths Building. All those are in New York City. There are plenty of other examples. And compartmentation is often the case in older buildings, just because of the way it's constructed. But modern buildings often have poor perimeter fire stopping and multiple penetrations for wiring. Now let's talk about pressurized stairways. In a high-rise, you may have one or more of the stairways that may be equipped to be pressurized when a fire occurs. The pressure differential will keep the stairways free of smoke. This requires a dependable source of power and intakes located so they will not pick up smoke from the fire. Occupants must be trained to use the proper stairway, in event of a fire. Now we'll discuss air standpipes. Post 9/11, some high-rises have been retrofitted with internal breathing air systems, or air standpipes. SCBA filling stations are housed every few floors. Firefighters can avoid carrying hundreds of SCBA cylinders up to staging areas. Now there's some installation of special equipment that occurs in high-rises. Equipment designed to function in case of fire should be installed under the supervision of the fire department. Fire department should be familiar with its operation and supervise its testing and maintenance, whatever that special equipment or system is. Continuing with high rises in terms of fire load and flame spread, consideration should be made of the interior trim and contents. Interior finish is often installed by the occupant without a building permit. Fires can gain great headway in combustible trim. And one example is multiple layers of wall coverings were a major factor in an Atlanta office building fire in which 10 people died. They had wallpaper on top of wallpaper on top of paint on top of wallpaper on top of paneling. So yeah, I actually am from Atlanta originally. Well, I was born in Maryland, but as I mentioned in an earlier slide, but grew up in Atlanta. And I'm familiar with this fire. Ideally, when buildings are redone, the old materials should be removed and the new materials should be put in. But to cut cost, unfortunately, that's not always the case. Now let's talk about contents in high rises. Very often it's an open floor plan and there's a quantity of electronic devices. And all of these have introduced new flame spread problems. The first interstate bank fire, which occurred in Los Angeles, this is a really famous fire, in which the fire spread rapidly while guards mistakenly reset the alarms. So this was in a year where you had some of these new open space designs and a lot more computers and electronic devices entering the workforce in huge quantities. So I encourage you to look this fire up because, yeah, it was a pretty major incident. Heavy fire loads may be found in special locations in high rises. Wood paneling and imitation wood beams and heavy loads of plastics are common. Storerooms for office supplies and telephone rooms are other high fire load areas. With maintenance operations, they can provide unexpectedly serious fire loads. One example is the Union Bank building fire in Los Angeles on July 18, 1988, where a contractor was refinishing bookcases with flammable liquids and ended up causing the fire. Let's discuss rubbish in high-rise buildings. Rubbish is often concentrated in one location. In high-rise building, you have like trash chutes. The condition of the material provides a high rate of heat release. Very often in trash, you have organic material. As it breaks down, it produces emissions, methane among them, sometimes. Collecting rubbish on elevators tempts the potential vandal. One example is a rubbish fire in an elevator that was parked at the 9th floor, and it contaminated the 26 floors above. Trash chutes deliver rubbish to huge compactor units located in the basement. There is an incident where 7 people died when a fire roared up 35 stories of a blocked trash chute. And we all know that dumpster fires occur quite often, and people are not often discriminatory about what they put down a trash chute. They don't think about the fact that you've got organic materials breaking down, releasing gases. They might even throw, empty an ashtray that has a lit cigarette in it down there, and that'll smolder. And sometimes they have oily rags that will self-combust and cause a dumpster fire. And if the trash chute's blocked, like in this case, the fire roared up 35 stories and killed a lot of people. Continuing with high rises, alterations to occupied buildings. Hazards exist when a building is altered or rehabilitated while occupied. Hotels are renovated periodically. New furniture is often stored wherever space is available. Mattresses removed from rooms may be stored in halls. Not the ideal situation, but it happens. One case where it went wrong is the DuPont Plaza Hotel in San Juan, Puerto Rico, where they stored a pile of new furniture, and it was stored in a ballroom, and a fire broke out, caused extensive damage to the hotel. So with high rises, let's talk about partial occupancy of buildings under construction. It is dangerous to have a building partially occupied and partially under construction, but it happens. Fire protection systems are not complete. Doors may not yet be installed on stairways and elevators. LPG or combustible liquids may be used in some areas. So there are a lot of hazards. Now let's talk about high rises and automatic sprinklers. Toxic gases released in a fire must be severely limited and not dependent on control by a smoke control system. The only such system available is automatic sprinklers. The argument against sprinklers is usually an economic one. It always boils down to money. But then you got to measure life versus money. To me, there's no, to many of us, there is no comparison. However, it's very often judged this way. The builder is creating the problem for profit. It is up to the builder to provide a solution. When the improvement of existing buildings is being discussed, many attorneys immediately dismiss any effort to improve the fire safety of an existing building as being unconstitutional. They don't always win this argument, but they do actually try and present it. Now let's talk about high rises in terms of checklist or building inventory. Information relating to building inventory is useful to the incident commander. In other words, you need to know what's in this building. Let's also talk about the structural frame. On this checklist, you need to know, is it cast iron? What is the estimated value of fireproofing? Are there connections from column voids to floor voids? All of this is stuff that needs to be checked before an incident occurs, of course. We've talked about this in other chapters. If there's steel, what type of fireproofing is used? Are columns unprotected in the plenum space? If there's predominance of concrete, are there visible rods and cracks? Has there been any fire experience in this building that might have caused structural damage? Is corridor fire resistance achieved by gypsum on studs, making breaching easy? If there's a lot of reinforced masonry, are there corridor walls that are reinforced? Continuing on that checklist, you need to talk about floor assemblies. If it's a bar joist floor to ceiling assembly, what is the integrity of the floor? Also, what needs to be considered is concrete. Are the floors of solid reinforced construction or composite decks? With post-tensioned, they should not be drill or cut, but they may have drill holes or cuts in them. Tile arches, these are dangerous to cut because the entire panel may collapse. Then you have the potential of overloaded floors. This has the potential for multi-story collapse. With floor containment, you have floor to ceiling assemblies. Again, this is continuing your checklist for high-rises. With floor to ceiling assemblies, the ceiling tile failure may permit at least partial collapse and open fire and smoke passage. You may have unprotected columns in the plenum where smoke and fire may pass to voids above via the re-entrance space. With fire stopping, is there effective fire stopping in void spaces? In regards to masonry floors, there may be utility openings that may allow fire to pass. With accommodation or access stairways, these create huge fire areas, as we talked about earlier in the chapter. With compartmentation, you have the integrity of compartmentation. Are there utility openings or underfloor openings such as for computer cables? Do barriers extend to the underside of the floor above? Do fire doors function properly? And again, all this is on your high-rise checklist. And continuing down that list, you may have gypsum board compartmentation, which is actually what we started with earlier in the chapter. If you have gypsum board compartmentation, consider penetration of relatively lightweight gypsum partitions as a substitute for forcible door entry. In regards to stairways, are there deficiencies of stair enclosures? Are there proper operating door enclosures on all floors? Are stairways locked to deny entry to floors? Do all units carry forcible entry tools? Elevators and other vertical shafts must be considered. Gypsum board enclosures may be destroyed by firefighting operations in these areas. With high-rises and fire protection systems, you need to look or consider sprinklers. Is the building fully sprinklered, or is it fully covered by sprinklers? And the standpipes, which type of standpipe system is provided, and where are those hose outlets? And there should be a level of smoke detection. Where are the smoke detectors located? And in terms of smoke management, does the building have a smoke management system? How does it work? What is it intended to achieve? And how do you operate it? And then, of course, firefighter communications. What kind of firefighter communication system does this high-rise building have? And occupant communications. Which type of communications are possible with building occupants? Can this system be controlled by floor or floors? And then equipment status. What are the indicators for fire pump, generator, and elevators? How are these pieces of equipment controlled from the command center? Now let's discuss hospital and nursing homes. In relation to non-ambulatory people, these are individuals that are not capable of self-preservation. The building, the staff, and you must protect them. In regards to older facilities, many lacked sprinkler protection. Many relied on passive protection. One example is an unsprinklered hospital in San Antonio in the late 1980s. The fire doors held the fire in check until firefighters extinguished the fire. One key to patient safety is to move them horizontally rather than vertically. Smoke barriers are 1-hour fire-rated walls that subdivide each floor into 2 or more separate areas. Now let's talk about RACE, the acronym RACE, R-A-C-E. R stands for remove all people in immediate danger to safety. A is activate the manual pull station and have someone call 911. C is close doors to confine the spread of smoke and fire. E is extinguish the fire if possible. RACE. R-A-C-E. Make sure you commit this to memory. In regards to hotels and motels, many serious fires have occurred in hotels and motels over the last 75 years. In 1990, a Hotel and Motel Fire Safety Act was passed. This encouraged improvements in fire safety for these facilities nationwide. Despite these improvements, fire fatalities continue to occur in hotels and motels. In older motels, fire spread occurs through voids between the floors and partially the space underneath the top floor and the roof. Newer hotels and motels have interior corridors that have proven to be a conduit for smoke travel. One case example for you to read about is the West Chase Hilton fire in 1982 that killed 12 people. That's West Chase, W-E-S-T-C-H-A-S-E, West Chase, all one word, West Chase Hilton fire, 1982. Jails and prisons produce a particular set of circumstances. In terms of inmates, they are restrained and incapable of getting out of the building to save their own lives. They rely on prison staff and the building for their safety. Facilities run the gamut from old to new, big to small, in regards to jails and prisons. Some use old technology and some new. Some have combinations of both as they were remodeled and added on to over the years. Some prisons and jails have full sprinkler protection, whereas others have none. And again, some have mixed. And there is old technology and new technology. There are 5 current occupancy classifications for jails and prisons. You need to make sure that you review these in your textbook. For use condition 1, this allows free movement and it's permitted within the building from smoke compartment to smoke compartment as well as to the exterior. Use condition 2 says free movement is permitted within the building from smoke compartment to smoke compartment. Use condition 3 is free movement permitted within the building within a smoke compartment. Movement to other areas is by remote control release. Use condition 4 is free movement permitted within an occupied space within a smoke compartment. Movement to other areas of the smoke compartment or other smoke compartments is by remote control release. And use condition 5 states that free movement is restricted from the occupied space. Manual release is necessary to allow movement from the occupied space to other areas of the smoke compartment or other smoke compartments. A case example for you to read about is one that occurred in Mitchell County, North Carolina, and this was a recent fire in 2002 that killed 8 inmates. This was a 1950s era facility that required manual opening of doors. Let's discuss starting of jail fires. Some jail fires start accidentally, but others are intentionally set by the inmates. Several fires over the years have involved the use of polyurethane foam in a padded cell. Some questions to ask regarding jails and prisons. Does a particular inmate facility have a sprinkler system? Is it a modern jail with smoke control systems? Does it have a smoke barrier, or does it have smoke barriers like those described earlier for hospitals? Are inmates evacuated from the building, and if so, where are the inmates then placed? We need to discuss also museums and libraries. There have been several recent museum and library fires. In 1986, there was the Los Angeles Library fire. And again, all of these you need to look up and read about. There was a Holocaust Museum fire in Terre Haute, Indiana in 2003. The Biblical Arts Center Museum fire occurred in Dallas in 2005. With museums and libraries, there are various fire suppression systems in place. However, they are not always available. Some institutions rejected sprinklers because they could cause too much water damage. Some facilities installed halon systems that are, of course, being phased out as halon is no longer the suppressant of choice. Life safety is a factor in museums and libraries, of course, and the primary concern is, in regards to life safety, is the protection of firefighters. And many museums and libraries have magnetic door locks. You'll also find these in hospitals as well, but these are illegal. The ones in hospitals tend to be electronic doors that are held by magnets that are then released and shut during a fire, but those just simply close the door to prevent the spread of fire, but they don't lock them. However, in museums, they have magnetic door locks. But again, these are illegal. Nevertheless, you'll find them. There is usually a pre-incident plan in place for museums and libraries, and this will assist greatly when a fire occurs. It needs to be ensured that the plan includes salvage operation details. One problem that you'll encounter in museums and libraries are library stacks. Libraries are the original high-stack storage buildings. Large main libraries have multi-level stack areas. A better system to guarantee the spread of fire and destruction of the books in case of fire can hardly be imagined. If you just look at the picture, you can see these stacks of books. And then one thing that also can occur is in a fire, the integrity of the shelves can be compromised, bringing a whole shelf over with hundreds of pounds of books. Nightclubs are particularly notorious in that there have been many tragedies connected with nightclubs. One of the more recent that certainly most people know about is the 2003 fire at a nightclub called The Station in West Warwick, Rhode Island, caused extensive loss of fire. Prior to that was a notorious fire that occurred at the Coconut Grove in Boston. And make sure when you look this up, it's spelled coconut, not in the traditional sense, but cocoa in the terms of chocolate sense. And it's spelled C-O-C-O-A-N-U-T, the Coconut Grove fire in Boston. You definitely need to read about that fire. There were so many violations that caused extreme loss of life. And prior to the Station fire in 2003, it was the most deadly nightclub fire in American history. And it was a terrible tragedy, as was the Station fire. But tragedy aside, there were many lessons to be learned, and you need to learn about it because of the number of violations that cause these fires to become particularly tragic. And also there were a number of regulations that were ignored that caused both of these fires to be tragic. So it wasn't just that there were violations that were that occurred, but also many rules and regulations that were in place that were patently ignored. Now let's talk about nightclubs within the club. Patrons who are not fully aware of their surroundings, that is a common state of affairs, and of course they're more than likely drinking alcohol. Clubs are often overcrowded. There sometimes can be locked egress doors, often at the rear, and all of these things complete the potential for a disaster. Many times nightclubs are old, worn-out structures, and many of these existing clubs are not required to retrofit sprinklers. Office buildings we need to discuss, of course. They come in the 5 types of construction. They are large and small, are high-rise or low-rise, and they're usually now built in the open office plan, which have low-height partitions that create cubicles for personal space, but the office is essentially one large open room, as you can see from this picture here, and certainly we're all familiar with that setup as far as offices are concerned. In regards to fire spread in an office building, in a compartmentalized space, a fire is much different than in an open office plan. In older office buildings, literally everyone had an office with a door. There were secretary pools, so to speak, where you had like maybe a cluster of secretaries working in a kind of a quasi-open area, or it was compartmentalized open area, but most people had individual offices with doors. That's an older compartmentalized office space. And nowadays what you find is more prevalent is an open office plan. We're going to return again to the One Meridian Plaza fire in Philadelphia, and I had stated earlier that there are so many things that this fire illustrates. And One Meridian Plaza we're going to return to here, and 3 firefighters lost their lives. So you need to read about it in terms of how that fire spread in the office environment. Another case example for you to review is a fire that occurred in Denver in 1992 where a firefighter was killed, and he ended up running out of air inside a smaller low-rise building. Now we're going to discuss open-air structures. Construction involves wood, or it could have an exposed wood plank roof. Such a building should be fully equipped with sprinklers. But the objection to sprinkler piping in an open decorative wood structure is, of course, understandable. In a building without sprinkler system, the best thing you can do in an open area structure without sprinkler is try to keep all kindling out of the way and minimize the minor light combustible structures or elements that can ignite the whole building. Now these are all considerations for the designer / architect. Small structures should have sprinkler protection. Parking garages may be partially or totally above grade and open to the atmosphere. All garages under buildings should have sprinkler systems in place. Dry standpipes mean it will take some time to get water to the nozzles of your hose lines. Restaurants are another type of building to be discussed. In restaurants, the common fire location is, of course, in the kitchen. Model building codes do not require a fire-rated separation between the kitchen and the dining area. Indeed, many restaurants, not all, of course, but in many restaurants, you sit down and you can see straight into the kitchen. There's no separation, except for maybe a partial wall. But you certainly see an opening where there's a food pass through many times. With restaurants, you also have cooking hood and extinguishing systems. Arthur Corbett, that we've referred to a couple times in this chapter, he wrote about cooking hood and extinguishing systems, and his experience with them has not been all positive. Many times the systems have failed. This is why inspection is so important. With restaurants, there should be a pre-incident plan in place, and attention should be paid to the location of the utilities, especially gas, and certainly when fire departments are inspecting, this all needs to be looked at carefully as well. And notes need to be made of the use of propane, and it is possible that you have propane or natural gas. One case example for you to look at is use of propane in a New Jersey Shore restaurant where patrons were forced to break windows to escape fire. That reference is a little bit general, but there are, unfortunately, many examples you could look up where this type of incident has occurred. Now let's discuss schools. Schools have building code regulations. These regulations, in part, are shaped by a terrible fire that occurred in 1958 in Chicago at Our Lady of Angels School. This tragedy led to better and more frequent fire drills and lower and more accessible windows for escape. Also in schools, you have the abatement of open stairwells, alarm systems, and fire-rated corridor and doors. There are some unique features of schools, one being that corridor widths are much larger than a typical hallway, and egress systems may be unusual as well. Some potential issues at schools is that not only are corridors wider than normal, they tend to be particularly long, where you've got classroom after classroom after classroom lined along these corridors. And special note should be made of hazards such as woodworking and machine shops. We've talked about in other chapters and in other fire classes how the fire department should be aware of buildings in their area, what all is contained in these buildings, etc., so that they're more prepared when an incident does occur. And one thing that a fire department needs to be aware of in schools in their area are lockdown procedures. And the department needs to be aware of how lockdowns will affect firefighting operations. And since the dawn of school shootings and other tragedies that have occurred in schools, you have enhancements, and some of these enhancements in schools may include bullet-resistant glass, secured lobbies, increased use of magnetic door locks, which are illegal, but they're there, locks on exits and room doors, thicker walls, and secure classrooms. Another type of building that firefighters need to be aware of are self-storage buildings. The number of these facilities has increased in recent years. They're usually construction types 1 through 4. They consist of one-story drive-up types also that are likely type 2 or type 3 construction. Those are the most typical ones, but not the exclusive type of construction. Some concerns are apparatus accessibility, water supply, and of course the contents of units is largely unknown, if it's known at all. And every unit's going to have something different in it. With self-storage buildings, you can have multi-story type 1 and type 4 facilities that present a challenge. These are often repurposed windowless buildings. Sometimes they're warehouses that have been converted. The concerns are confusing maze-like corridors. They all look perfectly identical. They have highly placed stored material and sometimes store hazardous materials. People are likely to put anything in there. Fire departments should try to use sprinkler discharge to help indicate a fire's location. Now we're going to discuss single-family homes. The California bungalow. This type of construction is popular all over the country. It consists generally of a peaked roof with rafters as small as 2 by 4 inches or 2 by 6 inches. Often there is no ridge beam in these homes. The attic often contains a high fire load of stored materials. And the house can have one or more dormer windows. The Cape Cod, very popular type of construction in the United States, and it consists of generally a 1.5 story home with a steep pitched roof. It is a platform framed structure. The stairway leads to the second floor, and it's usually located near the front door. Bedrooms may be located on both the first and second floors. And in this type of construction, it looks like there isn't a second floor, but there actually is. And in this particular Cape Cod, the windows face towards the backyard. There are windows on the back side of the building face the backyard, and that's the second story. And of course, the indomitable ranch house. That is the one of the favorites in the United States, and it generally contains open interiors, large attics, has extended overhangs. A lot of times these houses are spaced close together. Properly installed and maintained smoke detectors provide a high degree of occupant life safety. Hopefully they have them and they keep the batteries charged up. Often there is a failure to replace detectors in the attic. Then there's the split level. These are 3 floors joined by short run stairways. The top level usually contains the bedrooms. The middle level has the dining room, living room, and kitchen, and there's a lower level or a basement level, and these usually have the recreation room and laundry room. This structure is usually platform framed. Then there is the Victorian. It has a significant amount of ornamentation, steep pitched roof, and it's balloon frame construction. Now let's talk about stadia, which is the plural for stadium, and most major cities have a stadium. Seating capacity is a few thousand to more than 80,000. They can be open air or domed, and they're almost always type 1 construction. The type and amount of fire protection features vary. With a stadium, you have egress travel distance that is important. Most enclosed stadia cannot meet traditional limits from a remote seat to a fire-rated stairwell. Smoke management systems are now required. Additional fire suppression equipment can include traditional sprinkler systems, but they cannot respond to and control a fire more than 150 feet below their location. Flame detector activated water cannons have been used in some stadia. Now we'll review taxpayers and strip malls. Taxpayers, some characteristics of taxpayers locations are that they most often consist of ordinary type 3 construction, usually with brick-bearing walls and wood joist roof members. They commonly are 1 story in height, although the 2-story variety can be found in many jurisdictions with apartments on the second floor. Depending on the region, many taxpayers can have full or partial basements. Access to the basement is through metal sidewalk doors and stairs or interior trapdoors in the stores themselves. They are usually limited to approximately 6 to 10 small stores or other commercial establishments. and most often have cockloft or attic spaces. So these are taxpayer and strip malls. Taxpayer is a location where you have like a store or maybe 2 or 3 stores on the bottom level, and then 1 to 2 or 3 apartments in the levels above. Those are taxpayers. And then sometimes you'll find strip malls that are the same way, where you have it is a little strip, and it's got stores on the bottom level and maybe 1 apartment above each store in the upper level. Let's discuss fire spread in taxpayers. It's typically through the cockloft above all of the stores, and the parapet above the stores is usually unsupported or poorly supported. Movement of the structure below can cause the parapet to fall. Hazards include steel plates on the roof of check cashing establishments. Rotted wood floors under the wash machines and laundromats are also dangerous. Let's go into a little bit more detail with strip malls. Some characteristics of strip malls is that they may be of non-combustible, ordinary, or even wood frame construction, types 2, 3, and 5 construction, respectively. When made of non-combustible construction, strip malls have exterior walls of concrete block or concrete quote-unquote tilt walls, possibly with brick veneer, with steel bar joist roof members and a metal deck supporting a built-up roof. Contemporary ordinary construction strip malls use concrete block for exterior walls and solid wood joists or lightweight wood trusses to support a wood roof deck. Older ordinary construction strip malls may have a large bowstring truss, or may have large bowstring trusses. Some smaller strip malls may be built entirely of wood frame construction. Nearly all strip malls are 1-story, although a 2-story strip mall occasionally may be encountered. We're going to continue with some characteristics of taxpayers and strip malls. Based on region, strip malls may or may not have basements. They are usually larger than, strip malls are usually larger than the taxpayers and may have as many as 15 to 20 small stores and a large anchor store or 2. Strip malls usually have a greater store depth than taxpayers, and strip mall anchor stores, such as supermarkets, may be more than 150 feet deep, quite large, and they most often have a common cockloft or attic space. Let's talk about surroundings of strip malls. A parking lot can be helpful. You can place an apparatus on 4 sides of the structure. Additional apparatus can be placed in close proximity in the parking lot, and staging areas can be set up in the parking lot. Some disadvantages are that on-site private hydrants must be used because the strip mall is too far from public hydrants surrounding the property. The delivery truck driveway is located at the rear of the strip mall and is often dotted with crater-sized potholes that create hazards for fire apparatus and also firefighters on their feet. Be aware that you've got a lot of heavy loads moving in and out of there, and the pavement takes a lot of stress and strain and weight. So you can have large potholes that are a hazard to apparatus. You can also have some smaller ones that might not affect the apparatus, but you can break an ankle in them. So be aware of that. Some occupancy types for strip malls. They can have a variety of tenants, and therefore they present a variety of hazards, including flammable liquid, storage, use, and sales. The occupant count can range from dozens of young children in a child care center to a large group of patrons in a nightclub. Most building codes require a fire-rated separation between different occupancy types. However, no rated separation is required between a group of strip mall tenants if all are the same occupancy type. When a building area becomes too large, firewalls are often required to break the structure into smaller fire areas. Make sure that you review and are aware of local building codes. Strip malls of Type 3 and Type 5 construction that use combustible structural roof require the use of draft stops to compartmentalize the attic or floor void spaces. Draft stops are required to limit the size of attic compartments to 3,000 square feet and floor void compartments to 1,000 square feet. Installation of automatic sprinklers can eliminate the requirements for draft stops. Some building codes require fire stopping at a maximum of 20-foot intervals in combustible architectural trim. Structural fire resistance in strip malls mean that one way to increase the allowable area is to increase the fire resistance of the structural members. Fireproofing the steel is done by applying a fire-resistive coating that can increase the allowable area. Nightclubs of substantial size usually require a higher level of structural fire resistance in order to remain within the building code's allowable area limitations. It may also be the only occupancy within the building to have fireproofing. During pre-incident planning visits, look at the structural members in each occupancy. Sprinkler systems in strip malls mean that some building codes require automatic sprinklers for retail sales rooms larger than 12,000 square feet. Others require sprinklers for mercantile fire areas larger than 12,000 square feet. Some facts to know about these sprinkler systems. You need to know the areas of the strip mall that are sprinklered and whether the system provides complete protection, including combustible attic spaces, or it protects only certain areas. And you need to know the type of system, whether it's wet or dry. Note that many strip malls with unheated attics often leave unleased tenant spaces unheated, necessitating a dry system. The location or locations of the main riser control valve or valves is, of course, important to know, and be aware that these could be hidden in a closet of a tenant space. The location of the fire department connection needs to be known, as well as the areas of the building that it supplies. And also in pre-incident planning inspections, you need to, among all these other things I've talked about, you also need to be aware of the closest hydrant to the fire department connection. With utilities in strip malls, most modern strip malls have multiple utility meters and cutoffs. The meters and cutoffs should be identified by quote-unquote suite numbers. Note the location of the utility meter bank in your pre-incident plan. When it comes to forcible entry, you need to determine how you will gain access through the front and rear doors. Electronic and computer stores are now installing roll-down metal shutters, which create a double forcible entry situation. The rear door of a tenant space is heavily secured to prevent break-ins and may even have a drop-in metal bar, or have drop-in metal bars, plural. During your pre-incident planning visits, make sure the doors are identified by suite numbers. Some considerations in terms of firefighting. Remember that the fire can spread readily from tenant space to tenant space. A roof of solid wood joists with a drop ceiling below will allow fire to spread in this void space. A strip mall with steel bar joists and a built-up roof can be subject to a metal deck roof fire. You must get ahead of the fire. Fires in wood truss voids will spread rapidly due to the inherent openness of the truss. Ventilation can help slow horizontal fire spread through the roof area. We're going to discuss theaters now, and remember that theaters come in a variety of shapes and sizes. You have a theater such as the one in this picture here, and then you can have a movie theater. So they come in a wide variety of stages and platforms. With theaters, the stage usually has a proscenium arch and wall, which is the large ornamental opening and wall that separates the audience from the stage. And you see that quite readily in this illustration here. And this proscenium arch and wall that separates the audience from the stage also has hanging curtains, drops and scenery, and supports lighting and support rooms as well. There are rooms above the stage where you have stage hands that operate different parts of the theater. And of course, these are performing theaters that we're discussing right now. But then you have also movie theaters. Movie theaters do have usually a little bit of a stage, heavy drapes, and there are usually overhead compartments there as well, even if they're just for maintenance. With theaters, the platform has a raised area in a building for presentations. You can also have wrestling matches and the like where there are no hanging curtains, drops, or scenery other than lighting and sound effects. Requirements for stages. In terms of fire protection, more extensive fire protection requirements are required for stages rather than a simple open platform like you saw in the previous slide. There should be a fire-resistant proscenium curtain, flame-resistant scenery, and heat vents over the stage. Some more requirements for theater stages are that there must be a 2-hour rated separations between the stage and appurtenant rooms, sprinkler protection, Class 3 standpipes with 1.5-inch hose and nozzle. And this is a really important fire that you need to study, is the 1903 Iroquois Theater fire in Chicago. 602 people were killed within minutes, and many of the fire safety features did not work. There were also fire safety features that were negated by a decision to override these systems. For instance, one specific example from this fire, and there are so many things to draw from this fire, but one problem was that there were fire exits, and then management decided they looked, and they were marked, and management decided they looked unsightly, and they hung heavy drapes over them. So when the fire broke out, the audience had no idea that there were fire exit doors there behind those heavy curtains. So, but you absolutely need to study this fire. It was a great American tragedy, but it also led to copious amounts of improvements on the fire regulations that were in place and the codes. But they also led to many others that are still in use today, of course, and so many of the fire protection systems that you see in theaters were born of this tragedy. So definitely read about the 1903 fire at the Iroquois Theater in Chicago. There are underground buildings, and underground buildings must have an occupied level at least 30 feet below the level of quote-unquote exit discharge. That basically means exits that open onto street level. These buildings must have automatic sprinklers, standpipes, emergency power, fire alarm systems, PA systems, smoke management system, and smoke-proof enclosures. A smoke barrier must be added for buildings with the occupied level more than 60 feet below the level of exit discharge. You also have super deep buildings. Rail transit stations are the most common. One example is the 9/11 Museum at Ground Zero, and it's actually where the New York City Transit and New Jersey PATH trains ran underneath the World Trade Center. They're really, really deep, super deep buildings. Fire departments must be familiar with these buildings' designs. One example for you to study is the 1987 King's Cross Underground Station fire in London. 31 people were killed when a fire flashed over and spread throughout the station. Because of warehouses, which we're going to talk about now, large fires can happen anywhere, not just in big cities. So you can have a small town with a couple of large warehouses, and if a huge warehouse catches on fire, then you've got a major league fire that'll rival anything that you can find in a big city. In a warehouse, you have materials stored in solid piles or racks. A pile is storage that is either box on top of box or pallet load on top of pallet load. A rack is any combination of vertical, horizontal, and diagonal members that support stored materials. Some warehouse fire problems. You have factors that contribute to warehouse fires. You often have huge concentration of fuel. Tremendous dollar values are collected in these warehouses. Often you have few employees per unit of area. Sometimes in warehouses you have failure to segregate extra hazardous materials such as flammable liquids. Sometimes also there's a failure to raise the bottom layer of stock above the floor, thereby preventing water damage and possible collapse. Warehouses have a vulnerability to arson. The failure of management to give serious attention to a potential fire problem can lead to major incidents. Sometimes there is inadequate fire protection, either in initial design or in the maintenance of the warehouse itself. High rack storage in big box discount warehouses can pose significantly increased life hazard. And one example is 2007 loading dock fire in Charleston, South Carolina that resulted in 9 firefighter deaths. With pallets, you have pallets, and a lift truck allows stock to be stacked on these pallets, and the pallets can be stacked atop one another. The pallet storage system provides as much as 36 times the surface area as boxes stacked solid. Idle pallet storage, or pallets without the product, such as you see here in this picture, is a dangerous practice inside of buildings, and there are too many examples to even refer you to one, but if you go back through Los Angeles County in the last 5 years, I guarantee you're going to find several pallet fires. And pallet fires can occur outside or inside, but you'll see, if you just go by warehouses, sometimes you'll see pallets stacked outside like this, but sometimes they're stacked inside. And it's a dangerous practice, and pallet fires happen all the time, but the practice goes on, so you need to be aware of it. With warehouses, you also have shelving, and shelving creates miniature floors. One example is an estimated $14 million loss that occurred in a rack storage warehouse in Kennersville, North Carolina in March 1981. There are many other examples besides this one where shelving in warehouses caused problems. The NFPA 13 is the standard for the installation of sprinkler system, and as it applies to warehouses. Fire department connection, or FDC, was optional when this standard was written, but the NFPA 13 now requires the connection except for systems of 20 sprinklers or less. We now have modern rack storage warehouses. Rack storage buildings are now found across the country, and they're made with non-combustible construction, and the size can be virtually unlimited. You need to read about these more in detail through industry publications, fire publications, and also read about these in your textbook as well. When it comes to merchandise in warehouses, it's generally handled by mechanical equipment, and the operation can be fully or partially automated. In terms of rack storage warehouse fire resistance, like a multi-storied building without the fire resistance provided by even the poorest floor, in-rack sprinklers must be provided at intermediate levels. Early suppression fast response, or ESFR sprinklers, can suppress a fire without in-rack sprinklers. So you have in these rack storage warehouses, you have sometimes sprinkler systems that are built into the racks themselves. So, and then you also have the ESFR sprinklers. So sometimes they can act quickly to suppress a fire, even in a facility without in-rack sprinklers in place. Also in warehouses, you have dry storage of boats. These are special types of rack storage warehouses. They stack boats several lengths high in open or partially enclosed rack structures. The boats are of combustible fiberglass in most cases, or wood, and contain fuel. And even if they don't contain fuel, the tanks have vapors. And then you've got other combustible materials in the engine. You have oil, etc. Some concerns with warehouses. Modern contents of warehouses are increasingly higher hazard materials such as plastics, flammable liquids and gases, and chemicals. Huge quantities of material in one fire area provide fire loads that can easily overcome the best defenses. Higher and deeper aisles limit access and encroach on the space over the tops of piles required for effective sprinkler or hose stream operation. The size and construction of the buildings often make even the heaviest caliber fire streams ineffective. Automatic sprinkler systems, as installed, are often inadequate for the potential fire problem. Automatic sprinkler systems that are adequate for the job as installed can be defeated by changes in operation and storage patterns of the warehouse. Let's talk about warehouse buildings themselves. If a warehouse is concrete, it is inherently non-combustible. The building is not inherently fire-resistive. It can disintegrate or collapse, so make sure you bear that in mind. Concrete T-beam roofs are subject to spalling or disintegration of the concrete below the tendons. Conventional metal deck built-up roofs can burn independently of the original fire. With warehouses, you have static fire defense. Firewalls inside the steel structures. They probably are not freestanding. And passive fire protection is a material that is applied to a substrate and is designed to protect it from thermal effects. The integrity of the firewall depends on the active closing of fire doors when a fire occurs. In warehouses, you can have a solid masonry wall that is parapeted through the roof and is usually the most dependable fire barrier. Firewalls can be made of combined elements. There are dynamic fire defenses in warehouses. They consist of automatic sprinklers, and these have an unparalleled record of suppression or control of incipient fires. The record cannot be taken as an indication of what can happen in a high or dense storage warehouse. Every single fire is different. Every single warehouse is slightly different. So just because it was effective 85% of the time, you might encounter the 15% or 15 percentile fire where it isn't, or where things are different. You can have a failure in a sprinkler system in a warehouse fire. Early distortion and collapse of a steel roof from which the sprinkler system is suspended can occur, and this can be exacerbated by the exposure presented by a fire in stored pallets. We talked about pallet fires. Factory Mutual suggests limits on pallet height. There are very strict regulations on pallet height, and I can tell you now that it is exceeded persistently, inside storage or outside storage. In warehouses, you have fire hazards growing, where fixed oscillating nozzles may be used. Such systems are used at large lumber piles and refineries. Foam system protection is used in some warehouses, and some of these sprinkler systems deliver low expansion foam, and this is used for flammable liquid fires. And one example is Chicago Tribune's rolled paper warehouse, and it is protected with a massive high expansion foam system. Some attitudes towards warehouse fire protection boil down to management attitudes. and it is unlikely that management is fully familiar with the details of serious fires. An example is a major fire that occurred at the Smithsonian Institution. In a meeting afterwards, Arthur Brannigan was seated next to an official whom he knew had opposed the installation of a fire door. The official said, quote, "I've learned one thing here. If you design a major building, assume there will be a major fire," end quote. Another case example is an author named Corbett knows of warehouses built to handle less combustible materials, class 1 or 2, yet they were supposed to be able to handle class 4 and plastic commodities. Fire department actions at a warehouse fire. Of course, pre-incident planning needs to take place, and before construction takes place, there needs to be initial planning and plan review prior to that construction. And inspection of construction and witnessing of fire protection equipment tests needs to take place. Routine and special inspections during operations need to occur, and there should be a regular liaison with the warehouse manager between the fire department and the warehouse manager. And adequate planning for fire suppression is if and when. That should be the predominant mindset. If and when a fire occurs. With warehouses, you have initial pre-planning and review, and that includes a commodity letter program. And there should also be a check on water supply for sprinklers and manual firefighting capability. Standby diesel power should be adequate to replace electricity for fire pumps. In advance, there should be an establishment of evacuation routes and plan for potential air contamination. And the fire department should insist on fire department Siamese connection availability. Inspections that should occur during construction of a warehouse mean that fire department personnel should be present whenever acceptance tests are conducted. Routine and special inspections occur during warehouse construction, and during these, the fire department should try to achieve a cooperative attitude with management. And neatness of a warehouse or a warehouse construction scene does not always mean absence of a hazard. Warehouse personnel, once it is up and running, of course, too, warehouse personnel must be instructed to call fire department immediately upon suspicion of a fire. When working on pre-planning, a liaison officer must be completely informed on all factors that affect firefighting operations in that building. It is his or her job to see to it that all vital information is disseminated to all those who should have it. The warehouse manager should designate a specific senior subordinate to maintain a relationship with the fire department liaison officer. At a warehouse where there is a fire, you need to watch for these types of collapses or failures: a combustible metal deck roof fire, pretension concrete T-beams, truss roofs, connection or splices of heavy timbered roof, tilt slab walls outward and inward. Now let's talk about racks in warehouses. They may be erected across the openings at the far end of aisles and may result in dead-end aisles. There should be firefighter access doors available, and these should be every 100 feet in a high-piled stock warehouse. And the picture you see here on this slide is an example of a high-piled stock warehouse. The doors should be opened or forced early in the fire to provide emergency egress for firefighters. You also have solid rack shelves. Garment making generates huge amounts of combustible scraps. One of the worst fires in American history, but one that should be studied for many, many reasons, is the combustible scrap fire that occurred in the Triangle Shirtwaist Factory in New York in 1912. There's way too much in that fire to mention it all here, but not only was it caused by combustible scrap, but there were a lot of horrible things that occurred at that fire that result in permanent change of fire codes, not only in New York City, but across the United States. So in solid rack shelving, in garment manufacturing, the width of garment, one of the outcomes was that the width of garment cutting tables is permitted to be 48 inches. Some jurisdictions have erroneously interpreted the 48-inch concept to permit several levels of unsprinklered shelving no more than 48 inches wide, which is of course incorrect. Racks in retail big box stores have shelves that block sprinkler spray. Something to look at next time you go shopping. When regarding ventilation of a warehouse fire, is it better to close up the building and let sprinklers do the job, or vent it and attempt a combined manual/automatic attack? Partisans of each approach present convincing arguments. One case example is smoke removal fans that were used for a walk-in dumpster fire that filled Sam's Wholesale Club with smoke. So it's kind of a toss-up. There are people convinced that one style is better than the other, and it's going to boil down to the judgment used for a particular incident as to which technique is going to be the better for that particular incident. In a warehouse, smoke can bank down to the floor, leaving firefighters unsure of the way out. The best thing to do is follow the hose back to safety if you get lost. However, sometimes you have hose lines that are fed from an interior hose outlet. That's not a lifeline. The hose lines that need to be followed are the hoses that come off the apparatus. In regards to personal safety in a warehouse, all planning should always place the safety of firefighters first. And that's true at every scene. And if you don't take care of your own personal safety and that of your crew, that's paramount. No one else is going to be able to take care of it for you. You're going to have to handle your own safety and that of your crew right there where you are at any given moment. And then, of course, you have the officers who are working on the safety for the whole entire scene as well. So let's summarize what we went over in this chapter, and it's quite a bit. Occupancy plays a role in how a building is constructed. Combustible multiple dwellings include garden apartments as well as modern row houses and townhouses and similar structures like three-deckers. From a fire protection standpoint, atria are large voids that pass through multiple floors, allowing smoke and heat to move vertically through a building. Houses of worship span the 5 basic types of construction and can present a myriad of challenges for firefighters. We also talked about how a covered mall is a single building enclosing a number of tenants, including retail stores, drinking and dining establishments, entertainment facilities, offices, and other similar uses where the tenants have an opening onto one or more malls. We talked about the key to safe operations in a factory is first to understand what is to be made in the structure and how it will be made, and also how the structure has been designed and or altered to meet these manufacturing needs. Most fire codes require the creation of an HMMP and an HMIS that firefighters can consult when an incident occurs at a building where hazardous materials are produced or stored. We talked about how it is also a serious error to consider all high-rise buildings as a single problem. There are fire significant construction differences among high-rises. And if you remember, we talked about high-rise construction from different eras. Make sure to go back and review those. Hospitals and nursing homes we talked about and how they have a common characteristic. They are home to numerous non-ambulatory people. It is up to the building, staff, and firefighters to protect them. Although sprinklers are considered critical for large hotels, small motels are not required to meet this requirement. We talked also about jails and how they are considered institutional occupancies like hospitals. The inmates of a jail, however, are restrained and incapable of getting out of the building to save their own lives. They rely on prison staff and the building itself for their own safety. Unfortunately, museums and libraries, which we talked about, are not always protected with a fire suppression system. For many years, many institutions mistakenly rejected sprinklers as potentially causing too much water damage. And we talked about nightclubs and how they are places where people go to have fun. The use of alcohol is a key element of that fun, resulting in patrons who are not always fully aware of their surroundings. In addition, these clubs are often overcrowded beyond code-imposed limits. We discussed office buildings and how they are built in all 5 types of construction, large and small, high-rise or low-rise. And these buildings have changed over the years from highly compartmentalized structures with offices for every worker to the more conventional modern open office plan. Many large open area structures such as churches and arenas are built of wood or have an exposed wood plank roof that compromises the ceiling. Such a valuable building should be fully sprinklered. We discussed restaurants, and when pre-incident planning for a restaurant, pay particular attention to the location of the utilities, especially gas. In self-storage buildings, we talked about how a smoky fire in a self-storage building will make it very difficult to establish which specific units are involved. And in stadiums, one notable issue with stadia is egress travel distance. Most enclosed stadia cannot meet the traditional limits on travel distance from the most remote seat to an enclosed fire-rated stairwell. In strip malls, firefighters will be confronted with a variety of hazards as well as a variety of occupancy types. And we talked about underground buildings. And because underground buildings such as rail transit stations may house thousands of occupants at any given moment, moving these people quickly up stairwells to grade is nearly impossible. And we discussed warehouses at length. The advent of warehouse rack storage has brought potential major fire problems to any place USA. Now class, as with every chapter, I encourage you to contact your instructor should you need help or clarification with any of the topics we covered here in Chapter 13. This is an extensive chapter and we covered a tremendous amount of material. Because it is so large, remember that this tool, in other words, this lecture and PowerPoint, should be a benefit as a supplement to your reading and understanding of the textbook itself. The text is much more comprehensive than this presentation and should be your primary source of information and explanation. And again, I wanted to state also that this tool we use here is a supplement to the overall concepts we covered in Chapter 13. And also, we covered very many examples, or very many case examples were brought up in this class. I encourage you with every chapter, but most especially this chapter, because there are so many different types of construction we reviewed, and there are so many incidents that go along with these. And some of them are particularly notable because they had an impact on every type of construction since they occurred. Make sure that you review and research these incidents so that not only does it cement your understanding of what we covered in this chapter and specific topics within this chapter, but also because they are important historically, and there is knowledge that you need to carry into into every aspect of your entire firefighting career. Class, as always, we thank you for your time and attention, and we will meet again for Chapter 14.